Good day, class. Today we're doing the limit review. We talked about limits throughout the class, and we covered limits before we left with the definition of derivative, and I just wanted to review you over that. Um, Go ahead and take 5 minutes to work on your do now. Um, it says find the vertical and horizontal asymptotes of the following functions. Go ahead and pause the video and take 5 minutes to work on that. Okay, welcome back. So here's the solution. Basically, all I did was factor out the top, factor out the bottom. Remember, the bottom gives us our vertical asymptote because it's a limit where the bottom where we cannot divide by 0. And so when x is equal to 5, our bottom is 0, and when x is equal to -4, our bottom is 0. And we can't divide by 0, so it gives us a vertical asymptote. And then remember, horizontal asymptotes, you take the leading coefficients and you factor them to, or divide them to get the horizontal asymptote. So 1x squared divided by 1x squared is equal to 1. So our horizontal asymptote is y equals 1. And then the next part, the top part was already factored. And the bottom part factored out to x plus 3, x plus 5. So remember, x cannot equal 3 and x cannot equal 5. Therefore, it creates a vertical asymptote. And to get your horizontal asymptote, the leading is x. And the leading right here is x squared. So x over x squared equals 1 over x. And as you take the limit as x goes to infinity. And so as x goes to infinity, we get closer and closer to y equals 0. Alrighty, let's move on. So remember, the definition of a limit is as a sequence continues forever, what point does it tend towards? This point is known as the limit. So if we're looking at this picture, we see our vertical asymptotes, but our limit as x goes to negative infinity, our limit is y equals -2, and as x goes to positive infinity, our limit y equals -2. So we need to talk about convergent versus divergent. We have seen this before in series. So if we're looking at 1, 3, 5, 7, our series can continue. It's adding 2. So we have a sub n plus 2, right? And we could add 2 forever. It's infinite. So therefore, this series is divergent. It doesn't go to a number. It's infinity. So divergent. Okay. Let's look at 2. We're going 0.49, 0.499, 0.499. So we keep on adding n to the end. So our series will look as 0.9 is being added times 0.1 to the power of n. So that's what we're doing to 3.4. So as we keep going, adding 9s, we're going to converge to 3.5. Okay, let's go to 3. We're going 1/10, -1 over 100, 1 over 1,000, -1 over 10,000. So it's oscillating from positive to negative. So let's look at it, just the positives. If we keep on going in the positive direction is getting closer and closer to 0. If we look at it in the negative direction, the negative direction is getting closer and closer to 0. So since both of them are going to 0, it is convergent towards 0. Okay. And then 20 over 27, we would have to just put in our calculators. So let's see. Let's see what 20 over 27 is. Go ahead and put in your calculator. So I get 0.74. 121 over 162. You get 0.7469. And then let's try 1640 over 2187. You get 0.7498. So we get closer and closer to 0.75. So therefore, it converges to 0.775. And then this last one, 3, 4, 3, 4, 3, 4. We can go 3, 4, 3, 4, 3, 4 forever. So we're going to call that divergent. It doesn't get close to either number. Alrighty. So let's move on to a limit. Limit of a sequence of gradient lines. Remember, a gradient line is the slope of a line, which we denote as m, which is equal to change in y over change in x. And so we can use this slope of a line to find a tangent line. And so remember, slope of a line, we're just simply going to take a point here and a point here. And so we don't know what those points are. We just know that they're points on a curve. And so we're going to call the first point x and the second point x plus h. We're going to say the distance is h. And so we can evaluate to get the y values. So we have f of x. And then we evaluate to get the y value here. So we plug that point in, x plus h. So f of x plus h. And that gives us our y values. And so if we're doing change in y, we take the difference. So this minus this, that gives us the difference. So we get f of x plus h minus f of x. To get the change in x, we have x plus h minus x, which is just simply h. And so we come up with this definition of a limit, because we want to find the tangent line. Remember, a tangent line touches the curve at exactly one point. And so we want to find that tangent line at one particular point. And so we continue to make h get closer and closer to being 0. The difference in between those 2 points. We make it close to 0, so we take the limit as h goes to 0 of our slope, which is f of x plus h minus f of x over h. And so we're able to find the tangent lines at whatever particular x value that we want to find it at by finding the slope. Excuse me, guys. I have a small cold. Okay. So it says, write an expression for the gradient of a single line for each of the functions. Simplify your expression. So we're going to use our equation, f of x plus h minus f of x over h as the limit of h approaches 0. And remember, h cannot be 0 because we cannot divide by 0. So we have to work it out to find the limit. So the first thing I'm going to do, 3x plus 4. 3x plus 4. I'm going to do this on another page so I can have more space. 3x plus 4 is our function. And the first thing it tells us to evaluate x plus h into the function and then minus the regular function. So if I plug in x plus h right there, plus 4, and then I subtract the function, 3x plus 4. I have to put in parentheses because I'm supposed to subtract everything. And then all over h, find the limit as h approaches 0. Okay, so let's work with this function. First, you have to distribute 3x plus 3h plus 4, and then distribute the negative into the parentheses, negative 3x minus 4, all over h. First things first, we need to cancel out our like terms. So 3x minus 3x cancels out, 4 minus 4 cancels out, and so that leaves me with 3h over h. And you're finding the limit as h approaches 0. So 3h divided by h, that cancels out and leaves me with just 3. So my gradient expression, my equation for my gradient or my equation for my slope is simply 3. Alrighty. So the next part wants me to do 2x squared minus 1. So let's erase this. 2x squared minus 1. Again, I need to replace x with x plus h. And then subtract the entire function. Oops. 2x squared minus 1 all over h. Take the limit as h approaches 0. Okay, so first I need to square that. So you get x squared plus 2xh plus h squared. That's what that is, squared in parentheses. Put the 2 on it right there, minus, and then minus, distribute the negative in, so minus 2x squared plus 1 all over h. Then I have to distribute this 2. So I get 2x squared plus 4xh plus 2h squared minus 1 minus 2x squared plus 1 all over h. Need to cancel out like terms. 2x squared minus 2x squared, negative 1 plus 1. Alrighty, and I rewrite what I have. I have 4xh plus 2h squared over h. I need to pull out my h. 4x plus 2h all over h, and I'm evaluating the limit as h approaches 0. Cancel out the h's. That gives me 4x plus 2h. I need to evaluate the h at 0. So 4x plus 2 times 0, which just leaves me with 4x. So my expression for my gradient line is 4x. All right, I want you to do this last one on your own. So go ahead and pause the video and take a few minutes to do the last one. Thank you. All right, welcome back. I hope you were super successful at doing the last one. In case you were not, let me go through the steps of helping you out. X squared plus 2x plus 3. Alrighty. Remember, you have to replace each of these x's with x plus h. And then you were supposed to go ahead and square that. Factor that in. Oops. Cancel out like terms. Rewrite it. Pull out the H. Cancel the H out. Evaluate the limit as H is equal to 0. That leaves you with 2x plus 2. And that's the equation for your gradient line. All right. It says use the definition of derivative, find the derivative of f, and hence find the gradient of the tangent line at the given value of x. So basically we're going to find, remember that finding the tangent is the same thing as finding the derivative. So we're going to find the derivative or the gradient of the tangent line, and then we're going to find the actual value of the gradient at that particular point of x. So let's get started. Find my gradient equation for 2x minus 3. Sorry. And then we're going to find the slope of the line at x equals 2. Alrighty. So first I have to find that, and then I have to plug in x equals 2. So I have 2x plus h minus 3 minus 2x minus 3 over h gives you 2x plus 2h minus 3 minus 2x minus 3 all over h. Find the limit as h approaches 0. 2x minus 2x negative 3. I'm sorry, that should have been plus 3. Cancel that out. That just leaves you 2h. 2h over h. Limit as h goes to 0. The h's cancel out, which just leaves you at 2. So since there is no x, our gradient is just 2. And that makes sense because this is already a straight line. So we have a straight line, and then at that particular straight line, where our tangent line at 2, that's would be something like this, touching at exactly 1 point. So that makes sense. Alrighty. So let's go to the next problem. 3x squared plus 2x and they want us to evaluate it at x equals negative 3. Alrighty, so again, 3x plus h squared plus 2x plus h, then minus 3x squared plus 2x all over h, limit as h approaches 0, we get 3x squared plus 2xh plus h squared. And then we got to factor the 2 in, so we get 2x plus 2h minus 3x squared minus 2x all over h. Multiply that 3 in, 3x squared plus 6xh plus 3h squared plus 2x plus 2h minus 3x squared minus 2x all over h. Limit as h approaches 0. Cancel out the like terms. That would be 3x squared minus 3x squared. 2x minus 2x, and then the rest have h. So we're going to factor out at h. So we have at h right there, which leaves us 6x plus 3h plus 2 all over h. And we're taking the limit as h approaches 0. We can cancel out the h. And 6x, let h be 0. Excuse me. So 6x plus 3 times 0 plus 2. All right. And so that just leaves you 6x plus 2. Find the gradient at x equals negative 3. So we have to plug in negative 3. 6 times negative 3 is negative 18. Negative 18 plus 2 is negative 16. So our slope of our line at x equals negative 3 is negative 16. So that means if you can picture it, we have a parabola, and then at somewhere at negative 3, we have a slope going like this that has a slope of negative 16 over 1. That's what the picture would look like. Alrighty. So I want you to pause the video and try the next one on your own. Good luck. All right, welcome back. I hope you are very successful at doing that. X squared minus x plus 2. And they want us to evaluate the slope at x equals 1. So we're going to find the slope at x equals 1 of that tangent line. So x plus h squared minus x plus h plus 2 minus x squared minus x plus 2 all over h, and we're going to find the limit as h approaches 0. All right, so you get x squared plus 2xh plus h squared minus x minus h plus 2 minus x squared plus x minus 2 all over h. We're going to cross out like terms. X squared minus that, 2 negative x plus x. All right. And so that leaves us, everything has a multiple of h, so we can pull that out. 2x plus 1h minus 1 all over h. Evaluate the limit as h approaches 0. And if you're confused where I got this -1, if we pull out 1h, remember we still have to put a 1 there, because we have to, when we multiply it back in, we have to get the -h. That's where I got the -1. All right, cancel out the h and then evaluate it at 0. So that's 2x plus 0 minus 1, which is just 2x minus 1. So the derivative is 2x minus 1. Let's find the gradient at x equals 1. So 2 times 1 minus 1 is 1. So our slope or gradient at x equals 1 is 1. Alrighty. And that is the end. Go ahead and go to the practice. I wish you all the best of luck. If you have any questions, feel free to email me. Thank you.